In this video, we'll review the full compilation and the associated warnings generated. Full compilation consists of a number of steps. 1. Analysis and synthesis, which checks for syntax errors in our Verilog descriptions and checks if our proposed description is buildable in digital logic. 2. A fitter, which assigns device-specific resources to the Verilog description. Number 3, an assembler, which generates programming files. 4. Timing analysis, which essentially ensures setup, hold, and propagation delay times specified within the design can actually be met with the proposed description and selected hardware. And finally, 5. An EDA netlist writer, which generates output files for any third-party EDA tools, ModelSim in our case. When you run your first full compilation of any new project, a number of warnings will be generated. We'll review each of these now and identify necessary fixes. First one to look at is warning 292013. It's a licensing specific warning and can simply be suppressed as shown in the video. For now, this is the only warning that should be suppressed. It's good practice to work top down on the warning list. The next warning, 15714, says there are incomplete I/O assignments in our design. We can fix this using a tool called the pin planner. The pin planner allows us to select pin location, drive strength, voltage, etc., and is very similar to writing a port initialization for a microcontroller. Pin location is selected by dragging and dropping a node name onto pin locations on the FPGA map. These locations were shown using the DE0 Nano user manual. For example, notice here that pin L10 on the FPGA is connected to switch 0 and pin W15 is connected to LED 0. The final step to eliminating the I/O assignments warning is to run the I/O assignment analysis. But before we do this, we must first remove all defaults from all the pin specifications as shown here. Once all the defaults have been removed, start the I/O assignment analysis. Let's now recompile the code to locate the next warning. A key step in the FPGA design cycle is timing analysis. Timing analysis essentially answers the question, can the proposed hardware description on the proposed hardware meet or exceed the specified timing constraints such as clock speed and signal delay? Warning 3302 says that this project is missing a Synopsys design constraints file. An SDC file is an industry standard file format used to specify details about timing and other constraints within the project. In order for this warning to disappear, we need to tell the timing analyzer about our timing specifications using an SDC file. Open the timing analyzer, locate the tasks pane, and double-click Create Timing Netlist. Also list all the assignments within our design that require constraints in the SDC file. Now we're going to use the Write SDC file option to create an SDC template. Stick with the same name that you've used for your project to keep everything simple. In the next step, we're going to create a clock for the design. Now, our example is very simple and doesn't contain any flip-flops, but most FPGA designs will have flip-flops. So, by default, every FPGA design will require some sort of clock assignment. We're going to add that clock assignment to our SDC file now. You'll notice that we stuck with the default period for this clock. Now, we're not really creating a clock per se, but rather a constraint for a clock. This means that any clock used within this design with this name must be capable of running at least this fast. Click Run and update your timing netlist prior to exiting the timing analyzer. On exit, make sure you save the SDC file. Recompile your code and notice that this time it compiles without any warnings.